Howdy! Well, that's the way we say hello in Canada. Hello, children. How are you people doing? I'm Saurabh Kumar Dutt, and I'm here to teach you people a little bit of mathematics. Now, children, here we are starting off with permutations, combinations, which tells you about the number of arrangements or say the number of groups that you can be having in a specific set of data. For that matter, there can be a choice of say two boys and two girls from a group of a few children, which are to be say selected for a debate competition. Further, we can even be having say a choice of a few numbers to form a specific code, right? All of these are examples when permutations and combinations are required to decide the number of patterns that can be formed. Now here, children, in order to study this, we will look up this in the specific order so that you can understand all of the things such that whenever a question comes to you on permutation and combination, you are able to crack it. Remember, these questions are very important as they are asked in different competitions also, like if you talk about competitions in management or say for the army, right? That is for NDA, CDS, banking examinations, and many other examinations to test your logic, right? So at the moment, children, what we are going to do is we will be looking up the first concept that is required to look up the sums in permutations and combinations, and that, children, is the principle of counting. Now, when we talk about the principle of counting, it is that if suppose we have a specific type of a work which can be done by say some m number of types, and say there's another work which it can be done by say some n number of types, then the total number of ways of doing both will be m into n, right? For that matter, let us have an example. Let's say there be a cricket team, and let's say there is a batsman who is very good at playing fast bowling, and let's say there are 4 fast bowlers, right? And if a choice has to be made for a bowler, then the choice can be made in 4 different ways. Similarly, on the other end, let's say there is a batsman who is very good in playing spin bowling, and say the team has 3 spin bowlers, then the 3 spin bowlers can then be chosen in 3 ways. Now the task can be done by choosing a bowler into say be a fast bowler or a spin bowler in the number of ways will be given by m into n, and here in this case it will be 4 into 3 ways, right? So this is known as the fundamental principle of counting, or the principle of multiplication also, because multiplication is that mathematical operation which we are using in making this principle of counting to come to a result, right? So now, children, let us discuss a few sums on this so that the concept of the principle of counting or the fundamental principle of multiplication becomes perfectly clear with you people. Now, children, this is the first sum for you people. Now I will give you some 10 seconds for trial, in which I like you people to quickly try it out, after which I'll discuss the sum. Okay, children, let's discuss the sum now. Here in this question, we've been given there are 20 buses running between Melbourne and Perth, right? So we are moving to Australia, where we are talking about 20 buses which are plying between Melbourne and Perth. If Anshul wants to go by a bus and also return by the same bus due to some reason, then how many ways can he do that by? So obviously, if there are 20 buses by which one can go from Melbourne to Perth and obviously back from Perth to Melbourne, then the number of ways can be here the selection done by will be 20 first for the number of buses which are moving between Melbourne and Perth, and then when he is to come back, right, then if he is to choose the same bus, right, then obviously he will be doing it by how many ways? Just the same bus as such. You will multiply that by 1 because only one bus is to be chosen, right? So initially the choice was 20, right? Later, he made it a point that he comes back by the same bus. The reason can be any. Probably he missed his luggage, so he probably can talk to the driver, or probably there is some driver who's driving he really likes, or probably the conductor who was serving very nice food. It can be anything, right? Due to some reason, he wants to come by the same bus. As such, the number of choices which were there at the beginning of the journey were 20, but once when he completed his journey and when he wanted to come back again from Perth to Melbourne, then he chooses the same bus. As such, the number of choices he has is 1. As such, the total number of ways in which he can have this journey will be 20 into 1, and obviously if you calculate that, that will come to 20 ways, right? So this is how the sums on the principle of counting is to be done, and it is that if suppose a specific work can be done by say some m ways, and there's another work which can be done by say some n ways, then the total number of ways of doing the work will become equal to m into n ways, right? So here we had the sum. I'm sure you people must have been clear about this and must be waiting for the next sum. So here children, we have the next sum. Quickly give it a try, after which I'll be discussing the sum with you people. Okay children, discussing the sum now. Here in the question we've been given, in how many ways can 2 prizes in science and maths be won by 15 students? So let's say that there are 15 students in a class and there are 2 prizes, one in maths and the other in science, right? So here if you talk about the number of prizes, then obviously the prizes can be won in maths by any of the 15 students. At the moment we are not talking about who is intellectual and who is not. Probably there is a question which has been asked in maths, and whosoever's logic say complies to that, then that person say is able to answer the question and probably can get a prize, right? Similarly, it also applies for science. So at the moment we are considering that each of the children have equal intellect, and we are not going to have a special criteria about some children to be academically sound and the others to be not. So we can now say that this prize can be won by all the 15 children, right? That means all the 15 children stand an equal chance, right? So if we talk about the number of ways that we can give the prize in science, right, and the prize in maths, so the number of ways children of say a single subject at a time, number of ways of winning maths prize will become equal to any of the 15 children. As such, here we are going to write it to be 15, right? And then now we talk about the other, that is a number of ways of winning prize in science, right, can obviously again be equal to 15. Why so? Because the prize is not necessarily to be won in maths and not to be in science. As such, the boy or the girl who wins a prize in maths can obviously also win a prize in science. That means he can be able to probably compete in an examination where he or she gets the highest marks. So as such, the total number of ways of winning the prizes, right, will become equal to how much? It will become equal to 15 for maths and 15 for science. As such, it will become equal to 225, which is the square of 15 ways by means of which this work can be done. So I'll just quickly discuss this. Here in the question we've been given that there is a competition, right, in which there are 15 students who are competing, and there are 2 prizes to be won, one in maths and the other in science, right? So each of the 15 students are say said to be having equally intellect, right? As such, they stand all a equal chance of winning the prizes. Now, the number of ways by means of which any of the 15 children can win the prize in maths, given that they are all equal in their attribute with maths, will be 15. And similarly, if we talk about the number of children who have the capability of winning a prize in science, will again be 15, because one person who has won the prize in maths can get the second prize in science also, which is the only prize in science. That means a single boy or a single girl can get the prize in maths as well as in science. So as such, to win the prize in science also has 15 options, and that is the reason the total number of ways by means of which both the prizes can be won will be the number of cases that we have of both of these, and then we employ the principle of multiplication or the fundamental principle of counting, and then we'll have 50 into 15, which will become equal to 225 ways by means of which the work can be done. Is this clear with everybody? For sure? Shubham? That's good. Now children, we will move on to the next sum. Now children, this is the next sum. Quickly give it a try, after which I'll be discussing the sum with you people. Okay children, discussing the sum now. How many two-digit even numbers can be formed out of the digits 1, 2, 3, 4, 5 if the digits can A, repeat, B, not repeat, right? So here children, we have 5 digits 1, 2, 3, 4, 5, and remember we require two-digit even numbers. So the first thing that we're going to do here is we will now be making 2 spaces which will represent the digits which can be taken to make the two-digit number. Now as even numbers are required, so out of the numbers which are 1, 2, 3, 4, 5, we are just left out with 2 digits which can form even numbers, that is 2 and 4. And that is the reason if you talk about the units place, the units place can thus be written by only 2 ways, right? And this is the number of ways by means of which the units digit or this work can be done. Now if we talk about here the first part is when we talk about the digits to repeat. That means it doesn't matter if we have a 4 here, right? So let's say 4 comes here, so it doesn't matter that 4 comes here as a number, right? We can take that number 4 again. For that matter, 44 can become a number, right? So it also being an even number, it can be taken, and that is the reason why the number of ways by means of which the tens place can be written will be all the 5 digits, right? And thus the total number of ways by means of which you can do this work will be 5 into 2, that is the total number of ways will be 10 ways by means of which this two-digit even number can be written such that the digits can be repeated. Now children, if we talk about these 5 digits again, and then if for the second case when the digits will not be repeated is to be taken, again we have 2 places which will represent the 2-digit number. The first is the tens digit and the second is the units digit. And if we start looking up from the right hand side, the first is the units digit and the second is the tens digit. Now since here we require a even number, so as such the units digit can only be written by 2 or by 4. So it can be written by means of 2 ways. And now children, if say we talk about the tens digit, as if a digit has come, it cannot come for a second time, as here we are talking about the not to repeat case. As such, only 4 digits can come here. And thus, if you talk about the number of ways by means of which the first work, that is getting a 10th digit, can be done is 4, and the number of ways by means of which the units digit can be done, this work can be done by 2 ways. So the total number of ways by means of which both of these works can be done will be 4 into 2, or in other words 8 will be the number of 2-digit numbers which are even numbers out of the digits 1, 2, 3, 4, 5 which can be formed. Right? So now children, I'll just quickly discuss. Here in the question you've been given how many 2-digit even numbers. Remember, here you have to be cautious about what all words you're reading. So these are even numbers that can be formed out of the digits 1, 2, 3, 4, 5 if the digits can A, repeat, B, not repeat. Right? So if you talk about a 2-digit number which has repeating digits, it'll be say something like 22, 11, right? So these are such 2-digit numbers where the digits are repeating. So the first case is where we can be having repeating digits. The second will be numbers like 12, 14, right? Or probably 24 where the digits are not repeating. So first, talking about the case where the digits are repeating, we will first talk about the units place. That is, we will make here 2 places, once for the tens place and the second for the units place. And since here we require a even number, so the units place can be written by only the 2 digits which are 2 and 4, right? And here, if you talk about the tens place, as here the digits can repeat. So if a digit has been used here, like suppose 4 has been used in the units place, in the tens place again it can come. As such, the number of choices that we have for the tens digit is 5 in number, that is all the digits 1, 2, 3, 4, 5. Right? Now children, next what you do is, if say we talk about here these digits, right, then we will use here the principle of counting, right? What is the principle of counting? The principle of counting tells us this, that if say we have a few works which can be done by say some m number of ways and say some n number of ways, then the total number of ways by means of which the work can be done will be m into n. So here also, as the tens digit can be worked up or can be found by means of 5 ways, and the units digit can be found out by 2 ways. So 5 into 2 will be the total number of ways by means of which we can get the different even numbers which had been formed from the numbers 1, 2, 3, 4, 5, such that repetition of digits is allowed. Now if we talk about the second part, we require to find out some such even numbers which can be formed out of these 5 digits 1, 2, 3, 4, 5, such that the repetition of digits is not allowed. So first children, we'll talk about the units place, and the units place again can be written by the 2 digits which are 2 and 4, right? Only then the number that will be formed will be an even number. After that, if we talk about the tens place, as any number which has come, like say 2, can not now come in the tens place, as the repetition of digits is not allowed. So it can now come in 5 minus 1, that is 4 number of ways, right? So the total number of ways by means of which this work can be done is 4 into 2, that is 8 ways, right? So these are the 2 type of questions which have been asked and now have also been answered. So is everybody clear about this? Yusuf? Sure? Good. Now children, after this I have this next sum for you people. Quickly give it a try, after which I'll be discussing the sum with you people. Right, now let's discuss the sum. In the question you've been given how many ways can 4 letters be posted in 5 letter boxes, right? So let's say we have 5 letter boxes here, right, and 4 letters which have been written either by one person or by say 4 different people, right, is to be posted in the letter boxes, right? So let's say now we talk about these letter boxes to be made, say something like this. Let's say this be the first letter box, this be the second letter box, this be the third letter box, fourth be this letterbox and fifth be this letterbox, right? Now in this letterbox, let's say we have 4 letters which have been written by Hamad are to be say posted, right? And now we will consider these letters to be say some L1, L2, L3 and L4, right? So it's Hamad's wish whether he posts the first letter into this box, or the second letter, or the third letter, or the fourth letter, or all the letters, or 2 or 3 letters into the first box, right? So if we talk about these, then these are actually box B1, then you have box B2, then you have box B3, box B4 and box B5. It is his choice in whichever box he wants to put the letters, because in a single box many letters can obviously be put in, right? I'm sure you people are in a generation where we no more use much of letter boxes, but I'm sure you people must have seen some letter boxes some places, right? For that matter, if you talk about the principal's office, or if you talk about some places which say are some restaurants, etc., there are some complaint letter boxes where you can put up some complaints, or you can put up some official letters, right? So these are just like boxes which have some slits within which some letters can be deposited. So in a box many letters can be deposited. As such, if you talk about the number of choices which the first letter has will be 5, because it can either be deposited in the first letter box, or say it can be deposited in the second letter box, or say it can be deposited in the third or the fourth or probably the fifth, right? As such, the total number of choices that the first letter box has for it being deposited, right, is 5 in number. Similarly, if we come to the second letter has 5 choices again, right? So again, it can be deposited in any of the 5 boxes, right? And then further we will now talk about here the third letter also has a choice of being deposited in any of the 5 boxes, given that say 2 letters have already been deposited in a single box. So obviously there is still going to be place that the third letter can be deposited in the same box. For that matter, it can be deposited in any of the boxes given Hamad's choice. Now the same applies also to the fourth letter, right? Now children, if we multiply all of these, because the first work can be done by 5 ways, the second work can be done by 5 ways, the third work of depositing the third letter and the work of depositing the fourth letter can again be done in 5 ways. So as such, by the principle of counting, it will be the product of all of these different ways by means of which these works can be done. As such, the total number of ways by means of which this work can be done will be 5 raised to the power 4. And if you calculate this, 5 square is 25, so it's going to be 25 and 25, that is 625 ways by means of which these letters can be deposited, right? So I'll just quickly discuss this. Here in the question, you've been given that there are 4 letters which have to be posted in 5 boxes, right? So these be the letter boxes where the 4 letters, right, are to be deposited. So if you talk about the first letter, it can either be deposited in B1, that is box 1, B2, B3, B4 or B5. Now similarly, if we talk about the second letter, after the first letter has been deposited in say B1, letter 2 can even be deposited in B1 because the box B1 will have enough space to take in 4 or many more letters, right? So as such, the letter 2 will also have a choice of being deposited in any of these 5 boxes. As such, the total number of choices or the total number of ways by means of this work of depositing this letter in a box is 5, and same applies to the other 2 letters even. And now children, because the first work can be done by 5 ways, the second by 5, the third by 5 and the fourth by 5, so now we will be applying the principle of counting or the principle of multiplication to multiply all of these choices, and thus we will get it to be 5 raised to the power 4, which comes to 5 square, that is 25 into 25, which becomes equal to 625 ways of doing this work. So has everybody been able to understand all of this? So this is how, children, the principle of counting or the principle of multiplication is applied, and I'm sure when this gets applied to permutations and combinations, you will also be able to apply it with ease. Bye children, do practice all of these sums and similar sums, and have a nice time. Bye.